There's 6 hormones that are really crucial with the digestive process, and there's more hormones that are involved in that process, and these particular hormones we're going to talk about also do other things. But if things are going awry with these hormones, it can create symptoms like burping and bloating and acid reflux and constipation and diarrhea, and can lead to issues like SIBO or small intestinal bacterial overgrowth and all kinds of trouble. So in this video, I want to jump over to the smart board and just kind of help you understand real quick what these hormones do, what can go wrong if everything isn't working correctly, and steps you can take to improve the scenario. Okay, this is going to be awesome, and it might freak some of you out just a little bit, but let me rip through these hormones and I'll kind of help you understand how they're involved in the digestive process, and then we'll come back and talk about things that can go wrong with them and why do I got to sit on the toilet for 12 hours at a time, and we can kind of break that down and steps you can take to improve these scenarios. So let's jump into it with Gastrin, and this is produced here in the stomach. And its job is to tell the stomach, hey, make some hydrochloric acid and these good juicy stuff so we can acidify this food and really break it down properly. So it's triggered by food coming into the stomach. Just the sensation of pushing against the sides of the walls of the stomach make that gastrin go higher. And also changes in the pH here in the stomach can cause the body to release this gastrin. So this is a very acidic environment here in the stomach, like battery acid, acidic. So when we put food in, we're not eating battery acid, so anything that we eat is really going to change the pH in the stomach. And so when it goes higher, a more alkaline pH, then gastrin comes up to say, hey, it's time to make this HCl so we can break down whatever's in here. Something's in here, we got to break it down, let's acidify it. So good job, gastrin. And then once this food is acidified and it comes down here into the duodenum, which is like the first part of the small intestine, some people will call this duodenum, but it's more fun to say duodenum. You'll thank me later. But when this acidic product comes down in here, then that triggers this cholecystokinin. And you don't need to know how to say cholecystokinin. Most of the cool kids just call it CCK. But if you do get a new puppy, you should name it cholecystokinin. And then you should send me a picture because puppies are so cute. And if you don't like puppies, then what's wrong with you? We'll cover that in a different video. But this cholecystokinin, its job is to kind of signal other things to happen. So it signals the gallbladder to say, hey, squirt some of this alkaline bile down here to kind of help us neutralize these acids, but more importantly, to help us emulsify or break down dietary fats. So that's a big job of cholecystokinin. Cholecystokinin also triggers the pancreas to kind of squirt out some enzymes to help us break this food down. And cholecystokinin works together with secretin. And secretin's job is to kind of tell the pancreas, hey, squirt out this bicarb. Bicarb is very alkaline and it helps us neutralize the acids that are coming from the stomach. But this secretin also tells this gallbladder up here, it kind of signals up into that area and says, let's put some water and some bicarb into the bile. And that makes that bile more on that alkaline side, so it can, when it comes down, it can help neutralize those acids too. So I view these 3 hormones as the most important hormones for the most important things that go on. And then gastrin here has this other cool job. It's not just telling the stomach to make hydrochloric acid when food comes in there. It also goes through the circulatory system and goes down here and tells the end of the small intestine to open up this valve called the ileocecal valve and push this food through from the small intestine into the large intestine. So it's like, hey, food's in here, we need to move some things along to kind of get things going. So that's another job of gastrin that's very important in this whole process. And next up is GIP, which stands for Gastric Inhibitory Peptide, but I'm certainly not going to keep saying that. And this job here kind of takes place when we bring in carbohydrates and sugars. Its job is to kind of tell the pancreas, hey, we're going to need some insulin to kind of process all these carbohydrates. So that's very important. And then Motilin kind of kicks in when we're not eating. It kind of kicks in, especially once this stomach is kind of emptied out. Its job is to kind of help things move through this intestinal tract and kind of clear out all of the leftover, food particles that are there and kind of clean everything out so that they don't block the ability for us to absorb all the nutrients in the food that's coming in. And we also want to clean out any bacteria here so we don't get a bacterial overgrowth that creates all those SIBO problems that we hear about, or small intestinal bacterial overgrowth and all the crazy discomfort that comes from that. So the Motilin is very important there just to kind of help clear all of this stuff out. And then ghrelin here, which is also known as the hunger hormone, is in charge of once this food leaves the stomach and once we need more nutrients, it's like goes high and says, hey, you need to be hungry. Go ahead and go get me a chicken pot pie. And what's also important with this ghrelin is that it also sends the signal to put more acid in the stomach. Now it does it in a different way than gastrin does. And the reason it does this is to kind of set up that stomach environment to digest food when it comes in. So the food doesn't have to come in and you have to totally wait for gastrin to make all this stomach acid here. Because the ghrelin signaled that stomach to become more acidic, hey, I'm hungry, there's going to be stuff coming in, go ahead and set up this environment so we can really digest this food when it comes in. So that's another important part of ghrelin. So when all of this is working correctly, then everything's going great. You just eat food and then you just go about your day. You know, it's funny to me that I often have to explain to clients that when you eat a meal, you shouldn't really experience anything. It shouldn't ruin the rest of your day and leave you balled up in the fetal position on your bed. You know, you just eat food and then you just go about your day. So when all of this stuff is working correctly, that's kind of how it works. Now let's go over what can go wrong here and why it can create so much trouble. First, let's look at this gastrin situation. So this gastrin, remember, is supposed to tell the stomach to make hydrochloric acid. But let's say that there's something going wrong where it doesn't have the ability to make that hydrochloric acid, which could happen for a wide variety of reasons. A lot of people turn off stomach acid on purpose on a daily basis with some type of PPI or acid reflux medication. So when that's the case, then the stomach can't make that hydrochloric acid, right? Sometimes people don't have enough nutrients to make that hydrochloric acid, or maybe there's resources missing and the body can't make the stomach acid. If somebody is really stressed, their boss is a real jerk, well, that pushes the body into this sympathetic fight and flight state of the autonomic nervous system. So for our digestive functions to be able to work correctly, the body needs to be able to move into this parasympathetic rest and digest state. So if someone's really stuck in that sympathetic fight or flight state, they might not have the ability to make that hydrochloric acid. Some people feel like that stress has the ability to restrict this gastrin production. So we've known for a long time that this sympathetic state can restrict digestion, but that may be part of what's going on. Now here's where this can become a big problem. Remember that the body makes gastrin to say, hey, I need stomach acid in here. So when that pH stays the same, it still stays in that alkaline range, then the body's just like, oh, I know, I'll just make more gastrin. That's what I do to signal the stomach to make hydrochloric acid, so I'll just make some more. And it just keeps making more, but the stomach acid never goes up. And I'll put a link in the description below to all these studies that we kind of talk about, and you can kind of dig into a lot of this information more if you want to dig more into that. But there's a great study that shows how high gastrin can go when somebody is using PPIs to turn off that stomach acid for an extended period of time. But remember, somebody doesn't need to be on a PPI for their body not to be able to make stomach acid. There's a lot of reasons that can happen. But when this gastrin is going high all the time, remember it has that other job. It's supposed to tell this ileocecal valve here to open up so that food can move through. So if it's going high and it's telling this to open up too much, now we have some ileocecal valve dysfunction, and all this bacteria here in the large intestine that's supposed to be there, that can be really beneficial to us, starts to move back into the small intestine, and now we get that SIBO issue that can create all those troubles. Now, this lack of stomach acid has the ability to throw a wrench in these guys too, this cholecystokinin and the secretin. They're basically triggered by the stomach acid coming down here, by the acidic product of that acid mixing with the food that you ate, moving down here into the duodenum. Now, cholecystokinin can also be signaled by dietary fats and even amino acids, really, but in order to break food down into amino acids, that comes from protein, we need stomach acid to be able to break that down into those amino acids. So it's really about this stomach acid coming down here. And this secretin can only be triggered by stomach acid. So this is a problem because if this is not acidic enough to trigger these things to happen, well, now the gallbladder is not being signaled to send this bile down to help us emulsify our dietary fats, so we can't process those fats correctly, and now the body can't really utilize those. It's also not telling the pancreas to put out these enzymes that can help us digest the food and actually get the nutrients out of the food that we're eating. And then if these enzymes are not being pushed out of the pancreas, they can stay in there and lead to some other troubles like pancreatic issues. Now the problem with the secretin is that if this secretin is not being signaled by this acid, then not only is the bicarb not coming out to neutralize whatever acids are, a lot of times these things will break down by just rotting and fermenting, which can make them a little bit more acidic. But if there's not enough acid to trigger these hormones here, now the bicarb is not going to come out. But secretin's other job, remember, is to tell this to put more water and bicarb into the bile too, which can really increase the volume of that bile. Now we have enough bile to come down and really help us digest our food correctly. Now, if the gallbladder is not sending the bile on because the cholecystokinin is not telling it to, the gallbladder's job is to concentrate that bile so it becomes more effective. So the gallbladder will continue to concentrate that until it concentrates it into sludge or even stones. And now somebody's got to yank your gallbladder out and chuck it in the trash because there's too many stones in there creating too much trouble. So this secretin is very important to tell this gallbladder to put more water into the bile so it's easier to flow, but also more of this bicarb so that it helps alkalize everything the way that it's supposed to. So when this stomach acid is not there, these guys aren't really working. Somebody's going to, oh man, stupid hormones aren't working correctly. Well, they weren't told to do their job. It's not really the hormone's fault, is it? Now, when we're looking at GIP going amok, this is usually due to some type of insulin resistance issue. And when that insulin goes really high, too often, for too long, now the cells become less receptive to it, and this whole GIP pathway kind of breaks down. The good news is we can usually turn this around by just changing the way that we're eating. By consuming a more low carbohydrate diet, a person has the ability to bring their insulin levels down, especially for longer stretches of the day, and allow the cells become more receptive to that insulin. And then this whole pathway can start to work correctly again. Now, you're not going to eat a low-carb diet for a week and a half and fix insulin resistance. This takes time and effort. We'll put some links to some videos in the description below if you need to dig into this a little bit more. But the main thing is to have the ability to lower the carbohydrates. Now, from my experience from writing my book, Kick Your Fat in the Nuts, and from helping clients lose 235 pounds in a single year, I found that with a lot of obese clients that they're kind of gravitating more towards eating these carbohydrates and sugars because they feel lousy when they eat real food like proteins and fats. They don't have enough stomach acid to digest that food, or they don't have bile flowing well enough to emulsify their fats. So they're like, well, I'm not eating that. I feel lousy when I eat that. I can eat a toaster pastry. I feel fine when I do that. So they gravitate more towards these foods, and then they have a hard time lowering their insulin levels. So if a person can fix those digestive malfunctions, then they can eat real food. They feel great. They don't need all those carbohydrates and sugars, and it's a lot easier to bring down this insulin and fix these problems that are going wrong. So when we're looking at Motilin, remember that this becomes active when we're not eating. But when there's not enough stomach acid here, now we're going to have what's called delayed gastric emptying. Remember, the stomach's job is to acidify our food and then empty it out and send it on its way to do the rest of the digestive process. So if it hasn't acidified the food yet, why would it empty? Why wouldn't that be delayed? It's going to take longer for that food to break down by rotting and fermenting, so that process is going to be delayed. Now, if there's food in the stomach, to the body it's like, oh, I already have stuff in the stomach here, so why would the Motilin go into action if I just ate? It gives that sensation of you just ate, even if it's 6 hours later and it's just trying to digest. So now we don't have as much Motilin. Now the body kind of puts out Motilin all throughout the day, but the highest levels come when the stomach is empty. So if there's a problem with that stomach acid, we're not getting as much of this, so we're not doing as good of a job of that migrating motor complex that you hear about, getting kicked in and kind of cleaning all this out. That's what this kind of kicks into motion, is that MMC. And so without enough Motilin, that's not really going to happen, and a lot of people feel like that's what causes SIBO. So is the SIBO coming because this ileocecal valve didn't get closed right and things are going back in? Or is it because there's not enough Motilin to get all this stuff cleaned out and clean all the bacteria out like it's supposed to? You know, it could be one or both of those things going on. But this is really important to get into action, and we need the stomach to be emptied out for this to work the way that it's supposed to. Now, ghrelin has the ability to go high with stress, and that can elevate appetite, maybe cause a person to eat too much. But I find a lot of times with obesity kind of issues, it's a lot about the body's not getting the nutrients that it needs because it's not getting the nutrients out of the food that it's eating. It's not breaking it down well enough to do that, so it keeps screaming for more food. Hey, I didn't get the stuff I need, give me some more stuff. But real problems can happen when this goes too low. And this can often go too low when there's troubles here, and we're dealing with that insulin resistance type issues. Low ghrelin levels are very common to see with obesity. It's also common to see with delayed gastric emptying issues. And think about that. Why wouldn't it? Remember that this ghrelin's job when it goes higher is to help acidify the stomach more, to set it up so it can digest that food in an efficient manner and move it along. So if ghrelin levels are staying low, then we're not acidifying the stomach correctly before the food comes in, and then gastrin really acidifies that food. We're just not setting up the environment beforehand, so it's going to take a lot longer to move things along. It also sets up the environment to welcome in more bad guys. When this stomach acid isn't here because of all these problems, now all the bacteria and bad guys that come in on the food that you're eating set up camp and have a keg party. They're supposed to die in an acid bath here. So when this environment is not acidified correctly, they come in, they set up camp, they move down here in the small intestine, so that can be another source of trouble that way. So things that can make this ghrelin go too low can be like excess storage, like with obesity. The body's like, oh, I had plenty of fuel. I don't need to raise this ghrelin to get appetite to bring in more stuff. I got plenty of stuff here going on. The high insulin levels also do that same kind of mechanism. So those are things that need to be corrected so this ghrelin can be working correctly. Now, when we're looking at these things really working correctly, it's about acidifying the stomach. So a person might take steps to reduce their stress in their life. You know, one idea is like, hey, maybe you don't watch the news. Do you really have to watch the news every day? Oh, I need to be informed. Well, when have you ever watched the news and felt good afterwards? It doesn't happen. So do you really have to know all that stuff? It's affecting your health and affecting the way that your body is operating. If there's a real problem in the world, you're going to know because the store will be out of toilet paper. But reducing stress can be one thing that can help this work a little bit better. But a lot of people need to actually supplement with betaine HCl capsules to acidify that stomach and kind of get everything jump started. We'll put a study in the description below that I've talked about in a lot of other videos that showed that when they have this hypochlorhydria issue or low stomach acid, supplementing with these capsules has the ability to correct those symptoms that go along with low stomach acid. And just keep in mind that I'm not a doctor. I'm not giving you medical advice or telling you that you need to take HCl capsules. But if you look through those studies there, that'll give you more information to ask your doctors the right questions. I'm just a professional stand-up comic turned nutrition author because when I lost my voice for 8 years and had a lot of digestive issues, 23 different doctors couldn't help me figure that out. So I had to dig for my own answers. And now, 20 years later, I teach health professionals in more than 40 countries how to help their clients fix the actual underlying causes of health problems instead of just covering up the symptoms. So a person can kind of supplement with these capsules to get this working correctly, help them break down their food the way that they're supposed to, trigger all these hormones into action so that the bile can help get all the nutrients out of the food, all these enzymes, all that stuff has to happen. And now the body has the nutrients it needs to start making its own hydrochloric acid. And then a person can start using less of these betaine HCl capsules. I talk about how to do this the right way in a lot of videos. I'll put that in the description below as well. Chapters 3 and 4 in that book, Kick Your Fat in the Nuts, that I talked about, go over how to do this exactly. And that's available on Amazon, but I'll put a link in the description below where you can get that whole book totally for free and you can just jump to chapters 3 and 4. But getting this in motion, a lot of these things aren't working because the first hammer didn't drop. Why would they work if they're not being signaled to do their job? So that can become very important to acidify that stomach correctly, and a lot of these other things can happen. Now, effort still has to put into reducing your carbohydrates and all those kind of things, but we want this to happen. Now, one thing to understand is that just getting this acid to come down here into the duodenum may not be enough to get bile to drop down correctly if it hasn't been working for a long time. If it's stagnant in there and it's just sludge or stones, just being signaled isn't going to allow it to flow correctly. You may need to take steps to thin that out so that the bile can flow the way that it should. And there'll be a link in the description below for our video on 5 steps to improve bile flow if you feel like there's gallbladder problems. There's a lot of signs that can do that. We have a video on 10 signs of low bile flow. I'll put that below too. So you may have some more homework to get all these right, but it's nice to understand that, oh wow, all these things work together. A lot of the functions are more complicated than I explained here. There's other hormones that are involved in this process as well. I just wanted you to understand these main things that can really go wrong and help you understand that it's not always just the hormone's fault. People like to blame hormones because like, oh, let's just shove more hormones in you for $473 a month. But it's not always the hormone's fault. There's other malfunctions that are causing those hormones not to work the way that they're supposed to. So I hope that helps you understand a little bit. If you want more in-depth understanding of how to really dig into which aspects of digestion need help and the steps that'll really get you to improve those, you can jump over right now and check out our in-depth video on full digestive reset. I can't wait to hear about your results.